The article we chose is Researchers' AI-based speech sound therapy software wins $2.5 million NIH grant by Diane Sterling. This article discusses a $2.5 million grant that was given to the University of Syracuse to research and develop a clinically intuitive AI system designed to treat speech sound disorders. This speech motor chaining software contains an extensive library of speech sounds. Over 170,000 correctly and incorrectly produced R sounds made by 400 plus children were used to train the system. This system also features audio feedback of correct or not quite responses after an R production, followed by tongue position reminders with tongue animations. Additionally, the system is designed to increase word difficulty based on the child's productions. It is noted that the software is meant to supplement and not replace speech therapy. This project looks at whether AI-assisted speech therapy can increase the intensity of services through at-home practice between sessions with a human clinician, as the overall goal is to alleviate the impact of the worldwide shortage of SLPs. The author informs the audience about the research project by providing details about the project, its funding, and the researchers involved. While doing so, the author emphasizes the potential impact of chaining AI on improving speech therapy, particularly for children with speech sound disorders, and addresses the global shortage of SLPs. The article also mentions that ethical aspects of AI, such as fairness in assessments and adjustments for demographic factors, have been considered in the research, emphasizing the responsible development of the technology. Lastly, the author mentions the possibility of expanding the system to cover other sounds, dialects, and languages, highlighting the broader potential impact of the technology.
In class, we learned about the difference between covert and overt speech errors. Covert errors are errors that we monitor and adjust before actually articulating them. We are thought to have a self-monitoring system in which we review what we want to say before we actually articulate it. Overt errors, however, are speech errors that reach the articulation stage. These are the types of errors that the AI technology is being developed to detect, as many children with speech sound disorders require additional support to monitor whether productions are correct or incorrect. The article accurately interprets scientific information as the author directly communicated with the researchers involved in this experiment. The author's descriptions often build off of statements from the researchers, further describing the goals of the research team leading this initiative. The author was able to translate intricate scientific information into an understandable, accessible way.
The fact that the research project involves a principal investigator who is a professor of communication sciences and disorders, as well as co-principal investigators who are professors of electrical engineering and computer science, suggests that the research is interdisciplinary in nature. This interdisciplinary approach is often seen as an advantage in research projects, especially when tackling complex issues that require both domain-specific knowledge and technical expertise. In this case, the principal investigator from the field of communication sciences and disorders brings expertise in speech therapy, understanding the needs of individuals with speech sound disorders, and designing effective treatment approaches. The co-principal investigators from electrical engineering and computer science likely bring technical knowledge and skills related to AI, machine learning, and the development of AI systems. The article also acknowledges that the professors of electrical engineering have expertise in fair human-centric AI-based systems. The collaboration of experts from different backgrounds allows for a comprehensive approach to solving a real-world problem by combining insights from different disciplines. Naturally, a concern of the use of AI technology in speech pathology is that there will eventually no longer be a need for SLPs. Although this is what many of our minds go to, professionals are urging people to look at AI as an empowering tool instead of a danger to the field. In the ASHA article, How Will Artificial Intelligence Reshape Speech-Language Pathology Services in Practice in the Future?, SLP professors at the University of Arizona describe why they think AI will be extremely helpful in the speech pathology field. First and foremost, clinical documentation is one of the most challenging parts of our field. They explain that with the use of AI, we will be able to greatly shorten the time it takes to create and modify clinical documents. They describe that intelligent assistive technologies will be able to compensate for communicative and cognitive impairments. Additionally, objective assessment could become more automated and quickly reveal results. Lastly, it could help us to create more personalized care for our clients because AI technology will be able to track very specific patterns and characteristics of clients and their progress. Here are our questions for the class.